In this video, I'm going to do a couple multiplication problems involving rational expressions. And when multiplying rational expressions, you always want to see if you could factor first. So I'm going to take a look at this trinomial and see that factor out a 2 from both of them. So that's going to be the greatest common factor. So factoring out or dividing out a 2 leaves us with an x squared minus 2x plus 1. And that could be factored as well. That's x minus 1 times an x minus 1 because negative 1 times negative 1 gives us positive 1, and these two also add together to be a negative 2. The denominator of that trinomial can also be factored, and you could take out a greatest common factor of 4. So when we divide out a 4 from each of these terms, I'm left with an x minus 1. So far I have this part in the numerator, and then this part's going to be in the denominator. Well, this binomial up here can't be factored at all, so we leave it as is. However, we can factor this trinomial, and because there's a leading coefficient of a number other than 1, we need to use the box method. Well, you don't have to use the box method, but that's what I usually use. So here's my box, and I plug in my leading term here into this box. So I put my 5x squared there, and I take my constant at the end and I put it into this box. I multiply these two straight down to the right, and I'm left with a negative 30x squared. Now I'm going to list out all my factors of negative 30 and figure out which two add together to give us a 13x. So I know that we have a 1 times 30, and I'm going to make my smaller number a negative so that when we add them together, we're still resulting in a positive number. And then I know that negative 2 times 15 adds together to give us positive 13. So that's actually what we want. So I'm going to box this up in blue. I want a negative 2 and then a positive 15. And I plug them into these two remaining boxes. So that's going to be a negative 2x. Remember to put an x with it. And then this is going to be a 15x. And it doesn't matter which box we put these in. I could have put the 15x here and then a negative 2x here. Wouldn't matter. Now what I do is take out the greatest common factor from this top row, and that's going to be a 5x. And then I take out a greatest common factor between these two terms, which is just a 2, but because this box right here is a negative, we have to make our number negative. And then we take out the greatest common factor of this column, and that's going to be just an x. And then we take out the greatest common factor of this column, which is going to be a 3. And the reason why these two numbers stay positive is because these two boxes were positive. So now I have my two factors. I have x plus 3, that's coming from this x and this 3, and I have 5x minus 2 here, that's going to be my other factor. And at this point, I'm just going to rewrite my entire rational expression I started with and see what I come up with. And here it is. Now, when I have two rational expressions we're multiplying, what we do is just take the numerator here and multiply it by the numerator over here. And then the denominator over here multiplies this denominator. But we're not going to distribute everything because we wanted to come up with all the factors to see if anything in the top part cancels with anything in the bottom part. So where are my common factors? I have an x minus 1 on top as well as on bottom, so those go away. And I have a 5x minus 2 on top here, and a 5x minus 2 on the bottom there, so those also cancel out. Now I'm going to rewrite things. What I'm left with 2 times the quantity of x minus 1 over 4 times the quantity of x plus 3. And I know that 2 over 4 reduces to be just 1/2. So now I'm going to rewrite and get my final answer. So this is my final answer because 2 over 4 reduced to be 1 over 2. And then we have to also say that my x cannot equal a negative 3 because if you plug in a negative 3 for x, we're going to get a 0 here and we can never divide by 0. So this is going to be my final answer. In the second question, we're going to do the exact same thing as what we did in the first question. We're going to try to factor as much as we possibly can. So in the numerator right here, we could factor out using the greatest common factor. An 8 is divided out, so we're left with an x minus 3. And then in this denominator here, we could factor the trinomial. So we get x plus 6 times x minus 1. and we could factor this trinomial up here on the top. That gives us x plus 6 times x plus 3, and then this binomial down here is the difference of two squares. I could take the square root of x squared and then the square root of 9 and get x and a 3. So I rewrite two binomials like this: x minus 3, and then we also do an addition version where you got x plus 3. Okay, so now what cancels out? It looks like I have an x plus 3 on top and on bottom, so we could get rid of that. I also have an x minus 3 on top and on bottom, so I get rid of that. And then also an x plus 6 and this x plus 6, so that cancels out. And all we're left with is an 8 on top and an x minus 1 on bottom. So this is going to be my final answer, with the exception that my x value cannot equal a positive 1, because that would give us 0 in the denominator.